Study Section 8, Hypothesis Testing. Introduction. There is always some disagreement about the values of a parameter or the relationship between parameters. When parametric values are unknown, we estimate them through sample values. If the sample value is exactly the same as we claim, there is no problem in accepting it. In this study session, you will be introduced to statistical hypotheses and the steps involved, and also type 1 and 2 errors among others. Learning outcomes for study section 8. When you have studied this session, you should be able to define statistical hypotheses, list the basic steps involved in hypothesis testing, distinguish between one-tailed and two-tailed test, distinguish between type 1 and type 2 errors. Concepts of a hypothesis. The concept of a hypothesis can be summarized below. A statistical hypothesis is a claim, belief, or assumption about an unknown population parameter value. The methodology that enables a decision maker to draw inferences about population characteristics by analyzing the difference between the value of sample statistic and the corresponding hypothesized parameter value is called hypothesis testing. The statistic used to test a hypothesis is called a test statistic. The greater the difference between the value of the statistic and hypothesized parameter, the more doubt there is about the correctness of the hypothesis. The probability level at which the decision maker concludes that observed difference between the value of the test statistic and hypothesized parameter value cannot be due to chance is called the level of significance of the test. For example, a decision maker may feel that a difference that could occur by chance 5% of the time is not significant even if the hypothesis is correct. General procedure for hypothesis testing. To test the validity of the claim or assumption about the population parameter, a sample is drawn from the population and analyzed. The results of the analysis are used to decide whether the claim is true or not. The steps involved in hypothesis testing are summarized below. Step 1. State the null hypothesis H0 and alternative hypothesis H1. The null hypothesis refers to a hypothesized numerical value or range of values of the population parameter. It is usually expressed in the form of an equation which makes a claim regarding the specific value of the population parameter. For example, H0 population mean is equal to population mean naught, where mean is a population mean and may not represent hypothesized parameter value. On the other hand, the alternative hypothesis is the logical opposite of the null hypothesis. It states that the specific population parameter value is not equal to the value stated in the null hypothesis. For example, H1 such that population mean is not equal to hypothesized parameter. Consequently, H1 such that population mean is less than hypothesized parameter, or H1 such that population mean is greater than hypothesized parameter. Step 2. State the level of significance, alpha, for the test. The level of significance, usually denoted by alpha, is specified before the samples are drawn so that the results obtained should not influence the choice of the decision maker. It is the probability of rejecting the null hypothesis when it is true. This probability is usually very small, say 0.01, 0.05, 0.10, etc. Step 3. Establish critical or rejection region. Sample space of the experiment, which corresponds to the area under the sampling distribution curve of the test statistic, is divided into two mutually exclusive regions. These regions are called the acceptance region and the rejection or critical region. If the value of the test statistic falls into the acceptance region, the null hypothesis is accepted. If it is otherwise, it is rejected. The value of the sample statistic that separates the regions of acceptance and rejection is called critical value. Step 4. Calculate the suitable test statistic. The value of test statistic is calculated from the distribution of sample statistic by using the following formula. Test statistic is equal to value of sample statistic minus value of hypothesized population parameter over standard error of the sample statistic. Step 5. Reach a conclusion. Compare the calculated value of the test statistic with the critical value, also called standard table value of test statistic. If the calculated absolute value of a test statistic is more than or equal to its critical or table value, then reject the null hypothesis. If it is otherwise, accept it. One-tailed and two-tailed test. If an alternative hypothesis is such that it leads to two-sided alternatives to the null hypothesis, it is said to be a two-tailed test. For instance, testing H0 such that population mean is equal to 20 versus H1 such that population mean is not equal to 20 leads to two-sided test as mean can be greater than 20 or less than 20. In this situation, half of the area of critical region lies on the left tail and half on the right. If alpha is the area of the critical region, then alpha over 2 is the area on both the tails. Again, if the alternative hypothesis provides one one-sided alternative to H0, e.g. errors in hypothesis testing, there is a probability of committing an error in making a decision about a hypothesis. Hence, two types of errors are defined as follows. Error of rejecting null hypothesis when it is true, type 1 error. Error of accepting null hypothesis when it is false, type 2 error. Probability of type 1 error is denoted by alpha, and probability of type 2 error by beta. That is P reject null hypothesis / null hypothesis is true. Into bracket is equal to alpha. P into bracket accept null hypothesis stroke alternative hypothesis is true is equal to beta. The complement one minus alpha of the probability of type 1 error measures the probability level of not rejecting the true null hypothesis. It is also referred to as confidence level. Similarly, the probability of rejecting the false null hypothesis. It is also called the power of a statistical test. For a given level of significance alpha an increase in sample size will decrease beta value. Consequently, this increases the power of the test to detect that the null hypothesis is false. In other words, the level of type 2 error can be reduced either by considering a higher value of the level of significance, or by establishing the desired trade-off between these two types of errors.